Instead of bits, quantum computers use qubits. Rather than just being on or off, qubits can also be in what's called superposition, where they're both on and off at the same time, or somewhere on a spectrum between the two. Take a coin. If you flip it, it can either be heads or tails. But if you spin it, it's got a chance of landing on heads, and a chance of landing on tails. Until you measure it, by stopping the coin, it can be either. Superposition is like a spinning coin, and it's one of the things that makes quantum computers so powerful. A qubit allows for uncertainty. If you ask a normal computer to figure its way out of a maze, it will try every single branch in turn, ruling them all out individually until it finds the right one. A quantum computer can go down every path of the maze at once. It can hold uncertainty in its head. It's a bit like keeping a finger in the pages of a choose-your-own-adventure book. If your character dies, you can immediately choose a different path, instead of having to return to the start of the book. The other thing that qubits can do is called entanglement. Normally, if you flip two coins, the result of one coin toss has no bearing on the result of the other one. They're independent. In entanglement, two particles are linked together, even if they're physically separate. If one comes up heads, the other one will also be heads. It sounds like magic, and physicists still don't fully understand how or why it works. But in the realm of quantum computing, it means that you can move information around, even if it contains uncertainty. You can take that spinning coin and use it to perform complex calculations. And if you can string together multiple qubits, you can tackle problems that would take our best computers millions of years to solve.